get started. Enjoy the session, folks.
All right. Thanks, everyone. So today we are excited to have some great partners and friends with the folks over at LangChain join us for this discussion. We're going to be talking about RAG. This whole session today is about retrieval augmented generation. We're going to be exploring some of the advanced architectures and evolution in the space, sort of spearheaded by our folks at LangChain. And this is going to start with some introductions. I'll kind of introduce our guests. We're going to pass it over to them to talk a little bit about the evolution of RAG in the ecosystem and the particular role that LangChain has played to help shape that over the last year plus. We're going to spend some time talking about why access to data and data systems matter when you're building production scale generative AI applications. And then we're going to talk about Redis, of course, and our role sort of in this emerging generative AI stack. And it wouldn't be a webinar if we didn't have some kind of a hands-on example or demo. So at the end, we're going to get to wow you with kind of a real-time demo demonstrating LangChain and Redis together on a multimodal RAG example. So to kick things off, a brief introduction for myself. My name is Tyler. I am an applied AI engineer at Redis. I get to work really closely with our customers in the field, our partners in the ecosystem, and folks, open source and enterprise users of Redis all over the world for their uses of Redis and AI or ML related workloads. My background's as a software engineer and a machine learning engineer, and it's good to be here today. So I'm going to pass it over to Lance to introduce himself.
Yeah, great to be here. Can you hear us fine?
Yeah, we can hear you.
We have a little bit of background from some rain and thunderstorm here, but it should be fine. So I'm Lance. I'm one of the software engineers here at LangChain. I do a lot of work on the Python open source library. And over to Nuno.
I'm Nuno. I'm a software engineer here at LangChain. I do a lot of work on LangSmith and LangChain Core and LangGraph.
Awesome. Great. Well, it's great to have you guys here. As I mentioned in the beginning, the first thing we're going to do here is I'm actually going to hand it right over to you guys to talk a little bit about some of the foundational principles related to RAG and LLMs and sort of how you're seeing things shape up with the LangChain stack. So I'm going to hand it right over to you guys.
Yep, sounds great. Yeah, I'll start off with some basics on RAG, and then we'll pass it over to Nuno, who'll talk a little bit about LangSmith, LangServe, and our platform. So one of the main motivations of RAG is simply that LLMs have seen, of course, a lot of data, like very large-scale internet data, but they haven't usually seen your data. They haven't seen private data. They haven't seen particularly recent data. But there is something really nice in that these LLMs have increasingly large context windows in which we can insert data from external sources into them for processing. And actually, this chart is a little bit out of date because now we have Gemini 1.5, which goes up to 1 million in our context window on the y-axis. But the point is that LLMs are trained on large-scale but incomplete data, and we do have an opportunity to insert data into them. So you can kind of think about LLMs as like a kernel of a new kind of operating system, where the ability to take external data sources and input them is like a really central functionality. And so you can see that in kind of the lower left corner, external data sources connecting to the LLM context window is like a very central requirement. And RAG, or retrieval augmented generation, is a very popular overall paradigm to do this, where you have some corpus of documents, for example, say your private documents, that are indexed in such a way that you can retrieve relevant documents to an input question. So you can ask a question to the system, retrieve documents that are relevant, pass those relevant documents into an LLM to ground an answer to your question. So that's the general kind of pattern for RAG. And as mentioned before, indexing is really the central piece that makes documents easy to retrieve, usually involving taking documents, splitting them because, well, there can be many reasons to split them. We don't need to get into detail there, but typically split, index them, which means you basically take each document chunk and embed it such that you can then take an input question, embed it, and then perform some kind of similarity search on those embeddings to retrieve documents that are relevant to your input question. That's kind of the flow in a little bit more detail. And then this shows a little bit more intuition behind that similarity search process. You're taking documents, you're taking questions, you're embedding them into some high dimensional space. You're retrieving relevant documents to your question based upon similarity in this high dimensional space. That's kind of a visualization of that idea, just shown in 3 dimensions, just to make it easy to visualize. And really how this all comes together is that you do this retrieval in embedding space, you return documents that are relevant based on similarity, like we said, and now you basically plumb those documents into your LLM using a prompt. So we have many prompts for RAG. One popular one is you basically take the documents, you stuff them into a variable that we often call context. You also stuff in your question. And you have a prompt that says something like, given this context, answer the question. And the LLM goes ahead and performs generation to answer the question. But this is kind of connecting the world of retrieval to the world of LLMs using a prompt for RAG. And this is like kind of a data dump, but it shows you the full kind of landscape of RAG. And we may come back to this and speak on it a little bit more, but the way to think about this simply is that RAG is a series of different like submodules you can tie together to perform this. And so there's a lot of different techniques. For example, I show on the left in red for query translation. So take an input question, you can decompose it, you can rewrite it, you can fan it out into multiple sub-questions. Objective here being you want to modify a question to make retrieval better. You can route those questions to different data sources. You can construct queries as shown in yellow. For example, you can go text to SQL if you want to retrieve from a relational database, Cipher if you want to retrieve from a graph database. You can create metadata filters on the fly for vector databases. And of course, building your index is a whole kind of other area of work. I show a bunch of methods down at the bottom, which we don't need to get into, but we are going to show one of these later on. So it'll be fun to see that. Retrieval, then, of course, you can retrieve documents and you can compress them, you can rank them, and then finally you can perform generation. In that generation step, you actually can feed back, and we have some other interesting examples that we can speak to if you're interested. But this gives like the landscape of methods. There's lots of approaches in this world of RAG to consider, and we'll show a really fun one later on in this presentation. And then LangChain has many integrations to support this. As you can kind of see here, we have many different document loaders, embedding models, and indexes, Redis included, to build an index. We have many different query transformation methods, routing methods, post-processing, and over 100 LLM integrations. And I think I'll pass it over to Nuno now on the next slide.
Yeah, and then as you browse this wide variety of methods that we have available and the different RAG methods that you find in the latest research and that you can find in our templates or in our built-in modules, probably your first concern is going to be, how do you understand what's going on? So like that kind of act of debugging, just exactly what is being passed to the retriever, exactly what is the retriever returning, which documents, which parts of the document, what is exactly being passed to the LLM. That's super important as you actually test this out on your real use case and see if it actually does what you want it to do. And we found that the easiest way to do that is with an observability tool like LangSmith, where you can just see exactly what's going on in the calls that you are making to this chain that can become quite complex. And once you're happy with it, then the next step is you're probably going to want to put it in a production system of some kind. And at that point, a number of new challenges show up, like you're probably going to want to validate the data that goes in and the data that comes out and just know what kind of schema is expected. And that's something we support on all these chains with input and output schemas. And then once you have that, you're probably going to want to put it in, wrap it in a REST API so that, you can have another part of your system calls into this chain and just gets the response as an HTTP response and can do the rest of the thing it's trying to do. And that's something that you can easily do with LangServe. So that's something we have where any chain that you build, you can wrap it with LangServe and you get back a fast API application that does the validation and exposes all the batch, stream, invoke methods that you need. in order to have a REST API for your chain. And finally, you'd want to probably have some observability after you put it in production, just to have a high-level overview. What's going on? Is the latency behaving as I expected it to? Is anything, changing from day to day? And you can also achieve that with LangSmith. And all of these things work really well in isolation, but they also work really well when you use them all together. And the best way to see them in action all together is our templates. So I think we're going to show you particular templates further down the line. But yeah, you can probably find templates for pretty much anything you want to do with LLMs.
Yeah, that's awesome to hear. And we're definitely going to take a look at a couple templates later in the webinar this morning. And, I wanted to press in for a second actually on LangSmith because, this recently obviously hit like a big GA milestone. So congratulations on that. And it's received a ton of sort of positive and kind of overwhelming community support as well and interest. Can you speak to like how you're seeing the need for an observability tool like LangSmith deployed in different kind of scenarios, right? Like I imagine you have some customers and users of LangSmith that are okay with making kind of open internet calls to trace and debug and kind of have observability baked in. But then are there also ways and methods to have kind of an on-premise deployment model or solution for observability as well when privacy kind of matters the most? Is that something you guys are looking at?
Yeah, absolutely. We already have several customers using our self-hosted version, where you host it in your infrastructure, as long as you have the ability to run a Kubernetes cluster. So yeah, we're very flexible in terms of all of your requirements in terms of data privacy and where you want your data to be hosted, who has access to it, etc.
Got it. Yeah, that makes a ton of sense. And, with a tool like LangSmith, it's also providing this observability into, potentially very simple chains. Lance, like at the beginning when you were talking through kind of where the origins of RAG started, like being able to retrieve some data from a database, like a vector store, for example, and apply that and kind of stuff it, I think was the word you used, which is a good term for it, into the context window of an LLM at runtime. But then there's also like a number of sophisticated techniques which you highlighted here. And this might actually be kind of overwhelming for some of our listeners who maybe are seeing and hearing about RAG for the first time. I would love to know from what you guys are seeing in the field, both with open source users and your own customers, what are some of the low-hanging fruit techniques that they might want to consider looking at first if accuracy and quality is the most important thing in their system, like the ability to prevent hallucinations and make sure that it's grounded on factual domain specific data. Are there any techniques here that you would recommend as a good starting point to maybe get into?
Yeah, I can speak to that a bit, and then Nuno can also add. I think one of the most foundational things that new users typically experiment with that has significant impact is your indexing strategy, and in particular, your chunking strategy. The chunk size is kind of what determines, when you do retrieval, the size of chunks that you get back.
Right.
And if you make the chunk size really, really small, you're going to perform similarity search on very, very small chunks of information and return very, very small chunks of information. Likewise, if you do really, really large, you're going to be returning chunks that are obviously very large. I think with the advent of larger context LLMs, even a year ago, context windows were around 4 to 16K tokens. Now they're more 100,000 to 1 million.
Right.
I think that the stringency on building very, very small chunks is starting to kind of lessen. And we've seen pretty good results. I mean, embedding models have context windows up to say 8,000 tokens, for example, for OpenAI. Now there's some newer ones that are even more, but I think a general directive is actually can be a little bit less stringent with your chunk size and actually just embed larger chunks of information and use a larger context LLM. So if that means taking full documents and just embedding them in one piece, This actually can work increasingly well with large context LLMs to do the final generation, because there's a lot of challenges you run into if you try to make your chunks too small. You can break up important context, and this has been a problem for a long time. So I think thinking a lot about chunk size with respect to like the LLM you're using and your embedding model is like a really important vector to think about first and foremost. But anything
Yeah.
else that you kind of think about?
Uh, no, I would just add that I think as the technology improves, so does people's demands of the technology also go up. So now that context windows are larger, I think we may also start to see people trying to do things that were completely impossible before, and now still to make them possible still require really good chunking and uh, being really selective about what chunks you return back to the prompt, etc. Because you can imagine now, hey, now the prompt fits an entire book. Oh, so maybe
Right.
now I want an entire library
Yeah.
to be indexed, and that's not going to fit in the prompt.
Yeah.
So yeah, basically, I think it's a very interesting space where it's becoming very much easier to get started, but I think there's still quite a lot of stuff to do in order to enable all the use cases that we haven't thought of so far.
Yeah. One other small point that's occurred to me as Nuno was mentioning that is the approach that we're going to show here in your template actually is really interesting in general when you think about long context, because it's basically a take your document, summarize it, use the summary embedding for retrieval. But you can imagine that summary can link to a very large document. So you can actually do retrieval based on compressed summaries, but
Yep.
pass arbitrarily large documents to an LLM that has a million token context window. So it's a
Right.
nice way to maybe decouple the massive context window of your LLMs with a smaller context window of your embedding models, and also desire for your retrieval to be like a little bit more tightly scoped in terms of what you're actually embedding. So I think the technique that you're going to show here a little bit later is very relevant for this world of long context LLMs.
Yeah, for sure. And I like this too, because even just focusing on like text, for example, like you just mentioned the summaries concept, which I think kind of falls into the world of like what you have here on the diagram around hierarchical indexing.
Yep.
And, there's that big paper that came out, I guess, in the fall. I think it all goes so fast, I can't remember. But it was all about sort of the propositional sort of retriever, like taking the raw sort of context and actually asking some LLM to be able to like rewrite that into like concrete statements that have like a particular kind of verb usage and tense, so that it's really clear, it's really direct. Trying to minimize, obviously, introducing any hallucinations into that summary, but actually using then those like translated documents or summarized documents into those propositions as the core retrieval unit. Like that's what we embed. That's what we perform our vector search, our advanced search across. But then that links to the actual raw content that, like you're saying, we can kind of like include as part of the context window when it comes time to generate.
Yep, exactly. That's actually a reference in the blue section, the second box, multi-representation indexing.
Yep.
Dense X is that proposition-based approach, and that's kind of what we're going to show today.
Yeah, exactly.
The hierarchical thing is kind of is similar and also interesting, but not quite the same as what we're going to show.
Got it. That's great. Yeah. So, for everyone listening today, I think you've heard some good wisdom. Don't spend so much time freaking out about the chunk size. One, why? Because LLMs are continuing to advance. The technology, the compute, like everything is getting faster and wider. But I will say, like being on so many calls with users and customers, the number one thing that I get asked all the time, I'm sure you guys get asked this on Slack threads and on Discord and on GitHub all the time, is like, how should I pick my chunk size? Like I have this PDF, I have this paragraph, and they kind of ask it almost like, not because they don't know any better, but it's almost like asking, well, what value should I use for my epoch count for training my neural network? Or like, what value should I use like, as like a dropout parameter for a deep learning architecture? Like those things you kind of have to experiment with, right? You have to try a couple different things first. That's one of the pieces of wisdom that I try to encourage folks, is get some sort of kind of pipeline end to end with like a little basic evaluation set up, so that as you do make changes to the ETL or to the indexing structure or to the prompting, that you can actually measure some of those differences in responses.
Yep.
All right, well, I appreciate you guys kind of giving us the sort of overview of the landscape right now. And as you mentioned, LangChain does provide a ton of integrations and abstractions to make this incredibly easy for someone that is maybe getting started and looking for ways to kind of jumpstart. I know the pressure is there from boardrooms and executives all across the world. They're asking you to figure out how to use generative AI to improve their business. And I would go on the record to say here, along with many of you watching, I'm sure that LangChain provides a number of tools to help you do that really quickly. And so this is kind of the example that they were hinting at. We have this really interesting multimodal RAG example with Redis. We just kind of wanted to put this here for a second so you can absorb some of what we're going to get to talk about around like using, for example, PDFs and images with like diagrams and text. Very inherently multimodal data. We're going to use a language model that has vision capabilities in addition to text, of course. And then we're going to use sort of a data layer that's built by both a vector store and a doc store that can hold both the raw sort of bytes of the images themselves that have been extracted, as well as the text summary and the embeddings related to that text summary. And so this is an end-to-end kind of example we'll get to show here at the end, but we just wanted to tease it a little bit so you kind of knew what was coming. So I'm going to transition to a little bit of a section where we talk about some of the other things that we're starting to see emerge in the space, kind of why access to data matters. So you got a good overview of RAG, right, in general, around retrieval and a lot of the different concepts surrounding kind of a typical RAG pipeline. And, more often than not, I would say this very simplistic kind of 10,000 foot view of the stack is what I often run into when people are thinking about this from a system level. Like there's some kind of a human input, there's an application that takes it, does some kind of a thing with an LLM and returns a response. And like this is true, right, from like kind of again, that 10,000 foot view. But what we've actually seen emerge is that it's much more than that. And I think the bigger your company is and the more kind of like guarded your different data systems are from one another, the harder it is going to be to try to figure out how to dissect that onion. And I'll give one very small example. Like a financial services company that we work with has a heavily locked down sort of set of user groups that only have access to certain internal data, for example. Like there's external data that's like globally accessible, but then there's certain internal data sources, whether it's code, whether it's documentation, whether it's like transactions, or generally speaking, sensitive and like proprietary information related to users at the company or maybe customers. All of that's not accessible by every internal user of the system. So then you start having to figure out, well, how do I build, an authentication layer on top of this? And then we start trying to figure out how do we run queries, right, across potentially air-gapped data centers and be able to retrieve data from one place and bring it to another. Not to mention, right, like the large language models themselves, the embedding models themselves, are they exposed to the public internet? Are they running on premise, on your own hardware that you're having to manage and federate across, users across the system? And then, of course, you get into things like auditing and logging. Like, how do you make sure that your system is up and running kind of at scale and not only serving kind of in a performant manner, but also is of quality, right? Like with machine learning systems, there's this concept of like drift. This has been around for a number of years, whether it's a recommendation system or a fraud detection system. Like the underlying priors of both the data set and the model that you as a team trained change over time as data changes. And so that's the same here with some of these models too, is like your core data sources might be changing. The patterns of access and kind of the way that you're structuring the input to the model or even the model parameters themselves might be changing. And so you need the kind of tracking in place to monitor and audit for those things. Now, this may not matter, right? If you're a much smaller company or you're dealing with like non-proprietary data. But this is kind of a reality check, right? This is a little bit of a gut check. Again, I think one of the benefits here is we have partners like LangChain and others in the space who have built a lot of connectors and components to help manage some of these pieces. But it's something I wanted to highlight. And actually, I wanted to ask while they're here, like Lance and Nuno, how have you seen maybe some of your customers or users out there try to go about building this behemoth, that ends up being a really complicated system at the end of the day, not just something as simple as this diagram here. We can all do this probably, but this ends up being a little bit more complex.
My first port of call for this, I guess, would be try and isolate the complexity elsewhere. Like, does rate limiting, does caching, does session management really belong in your LLM application, or can it be handled by some other service that takes care of that externally? And if it's cached, it never gets called in here. If it's rate limited, the LLM application doesn't know about it because it never gets there. If the authentication is incorrect, then the same. And I think the more you isolate these concerns, the easier everything's going to be, I think, because you're not trying to, boil the ocean, solve every single problem inside your RAG application.
Yeah, that's great. And I think it definitely speaks to a certain point of this, is that what we're talking about with production sort of quality or enterprise quality RAG applications and applications that use LLMs in general is that what we've started to see is that a lot of the patterns for building and deployment mirror a lot of the same patterns of just like enterprise software, just in general, like exactly like you're saying. Some of those components around caching or maybe rate limiting, authentication, logging and monitoring end up getting factored into like separate systems that kind of are responsible for those. And I think that's exactly the way that if you're on the hook to try to figure out how to design the system at your company, don't look too much further than how some of the patterns have already emerged for a typical secure web app. And so this kind of has been one of the pieces of motivation and something that I've been thinking a lot about recently, which is, a lot of the architectures you saw earlier, right? These different techniques between query rewriting or document summarization, or even validation and like guardrails on the front end or the back end, or different styles of like retrieval and re-ranking, maybe that leverage either different external services or they leverage an LLM. Ultimately, what happens is that there's some kind of an application that does have to make multiple potentially steps or multiple inference steps with an LLM. And maybe it needs to make multiple reads to and from a data layer, whether it's like fetching some kind of a context history of your chat session, or maybe a summary of your most recent chat session. Of course, doing various forms of retrieval across like the domain specific data that you have. In addition to making LLM calls to do some of those tasks like query writing and expansion and validation. And so then you start to get into a scenario where very quickly you can rack up a latency budget that's potential in the order of multiple seconds. If we know anything about the internet and people using social media, people scrolling across websites and applications, is that real time is just like a thing of today's world. And I think everyone kind of has a little bit of a patience right now for sort of the fact that this is all new. So everyone's expecting maybe a couple seconds of delay between a question and some kind of an answer. But this only gets more complex, right? Like you could probably rack up maybe 5, 6 different LLM calls. Some of them might be smaller LLMs that are faster, a little bit specialized at a particular task. And some of them may be larger, like for example, a slower like GPT-4, for example. And so this kind of just underscores the need for real-time and also reliable and flexible data access within this architecture, regardless of how you're building it. And so, of course, this is like one of the areas for Redis that we can certainly help, like as you're looking to build these kinds of applications today, especially ones that go beyond just like kind of a simple demo for POV or POC purposes. And that's, Redis being kind of the home of our open source, vibrant database that's been around for over a decade now. It's obviously fast as an in-memory database, typically getting sub-millisecond latency on basic kind of fetches and writes. It's a key value store, NoSQL, kind of has an easy to use and intuitive notion to it. I won't brag on it too much more, but it's, it's one of the most popular downloaded and kind of databases across Docker and other hosting services. And then we're also the home of Redis Enterprise. And so we've taken kind of the open source core and wrapped it in layers that are needed typically for high scalability, high SLAs and uptime requirements, and of course, like security being another big key. And really at its core, the Redis paradigm is one where we have a number of data structures. It's not just key strings. There's lists, there's sets, there's even geospatial data support. There's full-on streams that could be potentially like a Kafka-like, data structure. There's hyperlogs, there's bitmaps, and then of course we have a little bit more extended data structures with vectors and JSON, time series, even probabilistic data structures like Bloom filters. And so this remote kind of server can act as a landing point for distributed systems that need to be either particularly chatty or they have really low latency write and read requirements. And it all kind of bundles up into this, for us, our enterprise tier product, which has a lot of the support for durability and kind of geo-distribution of data. So even things like active-active deployment, mechanisms for bidirectional replication, or even high availability, so you ensure you never lose access to that data, regardless of where it's deployed, and a scalability model where the architecture can scale with the size and workload of your data sets and access needs. And so these power a lot of use cases traditionally in the world of like caching and session management. That's where Redis has kind of had its heritage from. But a lot of people don't necessarily realize that it's also commonly used within like e-commerce, real-time inventory applications, where access to metadata like stock information about products on a retail site, for example, needs to be maybe updated and managed in real time so that you're not trying to purchase something, right, that's like actually out of stock. Or maybe game leaderboards where you have real-time stats and real-time information that needs to be aggregated and tracked across millions of users potentially. Or potentially even just as a primary database. Like people don't realize, but Redis does have persistence. Redis Enterprise has the ability to store data on disk and also back up in a couple different ways. And so we have a number of large companies and enterprises that are using it beyond the caching story. And so obviously that's kind of what we're talking a little about today. Vectors, right? Like it's the rage right now. Everyone's talking about vector databases and vector search. About 2 years ago, we added this additional data type and capability within Redis so that within maybe your JSON documents or your hash data structures, you can actually encode and store these embeddings that represent maybe images or text or potentially audio or segments of a video, you name it. We're completely agnostic to the different embedding model of choice. And a couple of patterns that have emerged beyond RAG, beyond the standard kind of vector search-based retrieval, is one around, again, a little bit more mature systems that have a common set of questions or users that ask familiar kinds of things, would be to prevent sort of never-ending calls to LLMs by quickly checking, has a question that's close enough or similar enough to some previously answered and validated question been answered, so that we can actually quickly short circuit and get back to the user both with a faster response, but also one that is cheaper because you didn't have to go through the whole process of using an LLM a couple times. And so there's some use cases where this makes more sense than others. Typically customer support scenarios, this actually works really well because there might be a set of FAQs or like really commonly asked questions that you can pre-cache into a Redis instance and put it right in front of your LLM so you can speed up your workflows. Another one is around actually providing some valuable session context to an LLM. So we've talked about retrieval of maybe like image embeddings or text embeddings to use as part of RAG. But another typically core piece of context to make a conversational AI system reliable and somewhat personalized is the idea of like the conversation history, the actual memory of your interactions, input and response to this LLM-based agent. And so this is one way you can offload pieces of this session context per user, maybe multiple sessions per user, into a lightweight database like Redis. You could store it in a list, potentially in a JSON object per user. There's a lot of different ways you can kind of build this pattern. But the idea here is to augment the LLM with additional capacity and additional context at runtime. Another area that I've started to see pop up is the need for really lightweight kind of semantic guardrail layers. There's a lot of different ways to build guardrails into a system like this, actually at different points in the call path as well. But one of them, and one of the most simplest ones, would be actually having a set of like pre-approved topics or statements vectorized into a vector store. And with the speed of Redis, being able to quickly check, hey, does this question from a user, is it close enough to a set of predefined or descriptive topics that are allowed? And if someone tries to ask something about like maybe PII or sensitive information or malicious kind of topics or inappropriate topics, that is a quick flag. You can actually prevent it from getting any further into the system without having to use an LLM in the first place. This is kind of a lightweight technique, and there are others for sure. And then lastly, the last technique here I wanted to highlight is really just about Redis as a lightweight document DB. And the goal here is to be able to enable kind of structured and unstructured or semi-structured data, whether it's text, of course, or numeric data, embeddings we've already talked about, but even audio snippets or images or portions of video that can be serialized or compressed and stored in Redis and accessible, in a very easy manner. Redis is another great solution here if you have different kinds of data that need to be persisted and accessed, quickly. So hopefully you heard a couple of these like maybe common issues that you might be running into, whether it's like around costs, especially for repetitive compute sort of scenarios, or maybe around accuracy, like really needing to make sure that your data sources are up to date. They're real time in the sense that that data is fresh the minute it becomes available. Or maybe it's around performance again, like making sure that your response times for your chat are not particularly laggy, as good as we can right now. And then security, making sure that the data that's in your vector store is locked down in a hardened database, but also that you can provide some level of contextual access control to your system kind of right out the gate. And these are just a couple issues that we've seen, and there's plenty more. And there's plenty of tools. There's no shortage of tools right now in terms of being able to solve some of the barriers that you're going to come across as you start to move these things to production. And before we jump in any further, I think it's often good to kind of be able to end a session with really good hands-on kind of real-world examples, because we just spent a lot of time talking at you. We want to make sure you kind of get to walk home from this session and actually feel like you have maybe something practical that you can get your hands wet with. So I'm really excited because we have a great framework to be able to use to teach some of these things and actually demonstrate some of these things in a way that you can actually go home right after this and try to reproduce it and try to build it yourself. So we have the LangChain templates framework that we're going to get to use. And actually, I would love for Lance or Nuno, for one of you guys maybe to chime in and share a little bit about some of the motivation behind templates and sort of like what role they serve, in today's landscape particularly.
So the basic idea with templates is just to serve as a good starting point that kind of encapsulates all the things that we've seen are useful when people try to put these LLM apps in production. So that's wrapping it in a fast API server, that's the validation, that's the LangSmith integration for debugging and observability, and just all in one single package. You download the folder, install, pip install, and off you go, and you can just run it. And the last thing I'd add is, I think Lance can speak more about this, but I think we try to make the templates be a place where we highlight cool new approaches that we've seen show up in the research, and just new use cases.
That is true. And actually, templates is where we initially showcased a lot of the multimodal RAG approaches. They're a pretty convenient way to like encapsulate a set of functionality that can be not only shared, but also like deployed really easily, as opposed to like just a cookbook or a notebook where you're sharing up a Jupyter notebook. This actually you can just run yourself really quickly. So it is a place where we've found it really helpful to encapsulate like new ideas
Yeah.
in a form that people can just grab for themselves and use.
Yeah.
And I think that's really the motivation.
Yeah, it's a great framework. It's a great approach. And for those watching today, like you'll need access to the LangChain CLI. You can use pip in some kind of a Python environment to install that. And as you can see, literally from there, it's basically 3 lines of code. You can create a new app really quickly, adding your own custom name, whatever it is that you're building. You just jump right into that repo, and then you can add templates from there. And the CLI is very straightforward, and it kind of gives you step-by-step instructions to kind of get started. And a couple months ago, at this point, back in the fall, at some point, we put out a very simple RAG example with Redis. And part of the motivation here was to, again, teach and show how simple it is at its core to get something up and running. And it kind of like goes right along with the notion and the purpose of the templates to begin with. And so for those of you that have like PDFs or documents that need to be processed and broken up into smaller chunks with embeddings created for each, this is a great place to just get started and see some of the techniques that are outlined both in the ingestion pipeline, but also for the serving layer. And what you'll find in there is that it's actually really simple. There's a grounded prompt that's created with some instructions, the original question that you input to the API, and some of the context that's fetched from the vector database. This doesn't include any kind of additional sort of nuance around like pre-processing or post-processing of either the query or the documents. So if you're really like brand new to RAG, this is actually a really great place to start because the code is quite simple to kind of get your head around. And of course, this features some of our partners at Hugging Face and OpenAI, as well as Redis. So this is the vanilla RAG template. There's a link here. You're more than welcome to go try that one, but that's not the one we're going to focus on today. So you've heard us reference things like multimodality, sort of different ways of indexing and structuring data for retrieval. Well, what we have here in this example we're going to show is a slide deck from Q3 of fiscal year 24, investor presentation for NVIDIA. So these are a set of PDFs that have raw text on them. They have images, they have graphics, tables. It's a lot of really complex information baked into the particular slide deck. So it's a great one to actually try to see if we can ask questions that it can try to answer for us. And the first thing that happens on this like ingestion pipeline is that we actually pass this folder of images through sort of like an image extraction pipeline where we use some libraries like Pillow, for example, and even NumPy to extract the raw data from those images. And we pass it over to GPT-4 Vision with the Vision preview enabled. And that model is actually responsible for taking an image, like a raw image, with a little bit of a prompting assistance. You'll see in the code base, but we give it some instructions to try to create a summary based on the image. And so this is actually creating a text paragraph or so that is a write-up of like what's going on in this particular image. I think is really interesting. We take then the classic sort of like ADA embedding model, or really any embedding model of your choice, and embed those pieces of text, like the summaries of those images. And we store those in a vector store in Redis. So we create an index on top of a set of hashes, in this case, that have a vector for each image summary. And then what we're also doing is we retain an identifier between those hashes with the embeddings to a separate, we'll call it a table for simplicity, but a separate set of hashes within the same Redis deployment or the same Redis instance that actually have the encoded images stored into Redis as a byte string. And from there, we now can tie search and retrieval over images with the actual raw image of this PDF slide deck, for example. So now at serving time, what this exposes is the ability for the user in this case to maybe ask a question of something that they might think, hey, the slideshow or this deck or these images might have an answer for me. We'll go through the same process you would for any basic RAG system where we're going to embed that query. Maybe you went through some query expansion or something upstream, but at the end of the day, we're going to get an ADA embedding from OpenAI in this case and run a vector search operation across Redis, across that index. And that's actually going to highlight the top K or maybe the top 3 or 4 images that are most relevant to that question. again, remember that we're actually doing the vector search across the text. We're doing a vector search across the text embeddings that are the summary of the image. And from there, we just do a quick lookup on the byte store, or really it's just a document store in this case. And that's going to pull out the actual raw images that are most related to the user question, at least theoretically. And from there, we're going to go back to our dear friend GPT-4 Vision and ask it with a little bit of prompting assistance. You'll see that in the code base as well. Generate the answer from this original question derived from these images. And so right there in that, using that kind of multimodal image and language model, we can generate grounded answers now from these images and from these slides. So this is a particularly novel technique if you have data that isn't just text and you're looking to try to take advantage of these multimodal LLMs and embeddings. And so hopefully what I'm going to show here will resonate well with everybody. So one of the things that we didn't even mention, at least I don't remember mentioning, was with the LangServe technology, is that they have this notion of a playground. And so every fast API server that gets deployed, you have this little playground environment that's the perfect testing ground for testing questions and actually seeing what you get back from the server. And just so everyone can also see what I'm looking at in terms of the code, I'm going to quickly drag this over. On the left here is actually the LangChain repository, and you'll see this folder under templates. There are a ton of different techniques. So whether it's using particular technologies or sort of like hello world examples, or maybe you have different techniques you want to explore, this is a great resource, right, to kind of use some of these to work with. And so here's our LangServe application that's running. This is using the LangChain CLI. We ran a simple command to spin up this template inside my application. And the good news is I did have this running and tested before we got on here. So fingers crossed we aren't going to see any issues with the live demo. But I'm actually going to test one interesting question here. Actually, I think, Lance, you recommended this as a good test question. We're going to ask this PDF from the investor slides, like, how much can an H100 TensorRT improve Llama 2 inference performance? And so this is, a little bit more difficult question than like, how many employees work at NVIDIA? And we'll see how this does. What I like about this too is that it actually logs intermediate steps. So you can actually see, here's my original question. And now we actually have the set of images. These are lovely bytes, so ignore the fact that it's a bunch of alphanumeric characters. We have the raw images that are fetched, and then the answer is generated here. That wasn't even that long. So H100 can improve inference by 4.6 times, as shown in the bar chart on the right side of the first image. So it gets us the answer, but it also links us to the particular place in the diagram that it came from.
Now, if you have Langsmith open, you will see the image rendered in Langsmith. So that might be a nice thing to showcase if you have that.
Yeah, that's a really great point. I don't have a running Langsmith instance at the moment.
Okay. Well, it's GA now, so you can sign right up.
Exactly. And this log output
this showcases why you need Langsmith. See, because then you're like, I don't actually know what this image is, but you go to Langsmith, it's all there. So This is a good illustration right there.
But that's a great point. And so yeah, you can see I'm scrolling forever through just a forest.
This will just be the base64 encoded string, so you won't actually get the image. You can go back to the slides to validate it, though. Go to the slide deck, and it might, the NVIDIA slides, wherever they are.
Yeah, let's see. There we go. Okay. So for those of you watching still, as we navigate this lovely PDF, here is the exact graphic where the answer comes from, which is the H100 TensorRT improves Llama 2 inference performance by 4.6. So notice that this is not just a paragraph, right, of raw text. It's actually a graphic, a diagram that has this information, and GPT-4 Vision, along with Redis and the rest of the LangChain stack, was able to mine for that piece of information. Yep, and we'll ask one more, because I think this one's another hard question that you came up with, Lance, when you were seeding this, which is what is the percentage change in GPU accelerated applications from 2020 to 2023? So let's see if we can answer that one. So I'm going to close my steps. I'm going to hit start. And notice that the steps immediately start racking up as you do that, as the streaming log output comes in. So we're getting little sections at a time from the LLM. And just to also take note, okay. So the output we got is to calculate the percentage. This is really interesting to me because it's saying, here are two numbers. We measured it in 2020. We were able to derive that from the PDF. And in 2023, here are the two numbers, and actually creates the formula to calculate the percentage change and shows you step by step how that calculation is rendered,
Yeah.
and then gives you the answer at the end.
Yeah.
So this is just hopefully kind of scratching the surface for those of you that might be, exploring the whole multimodal RAG scene. The good news is that the work that we've done here is going to be available really soon. We've got a PR that's open. The team's taking a look, and obviously we're going to make sure it's all up to speed. And once this gets released, we'll probably put out some kind of a blog so you can kind of get, a trial run with it. We'll give you some more context and kind of different prompts to try. But the goal here is to kind of kickstart you on your multimodal RAG journey. So unless there are any other points you guys wanted to make about the demo, I think we're pretty much at time to wrap it up here.
Yeah, that was great. Also relevant because NVIDIA actually reports earnings tomorrow, I believe. So it's their new earnings, but it's an interesting theme. And probably those new earnings will be out by the time this webinar is out.
Exactly.
So we'll see. You can take their new earnings report or slides and apply the same approach. So there you go.
Yeah, no, that's great insight. Exactly. So if you guys are watching, you can take the new PDFs that come out and try it with this template when it's ready.
Yeah.
We wanted to take a moment and obviously, thank you all for kind of being here and being good participants. But part of what we're continuing to do together as far as LangChain and Redis is concerned, we have a couple new things kind of coming down the pipe. So one is that the LangChain team recently released a JavaScript and TypeScript package that's dedicated for the Redis integration. So kind of the benefit of that, I would articulate from an engineering standpoint, is a little bit better dependency management, a little bit more reliable CI/CD because it's going to be kind of vetted and tested on its own cadence and released on its own cadence, and also a little bit more dedicated subject matter expertise on that particular integration touch point. And we're building one kind of as a collaboration with the team for Python as well. And that one's still coming soon, but be on the lookout in the ecosystem for when we launch that particular package. The other thing is that I already mentioned, the multimodal RAG template is going to be available soon for you all to use. The vanilla RAG template is already out there, and I've linked it below. And then, of course, there's a link here for all the things that you've seen today. You can go to redis.com/try-free. And from there, you'll get spun up on a really lightweight and free cloud instance that has access to vector search and a bunch of other things that are great. And that should get you started on your journey. And again, I want to take a moment, thank you all for being here. And I want to especially thank Lance and Nuno for joining us and sharing their insights. We couldn't do any of this in the AI community without their leadership and their help along the way. So thanks, everybody.
Yeah. Thank you. Thanks for all your work on the template. It's very cool to show that you can do the summary and image management all with Redis. Some of our other demos use like two different technologies for that. Like we'll index using Chroma. We will store documents using Upstash. So it's nice that it's all one thing. That is pretty cool.
Yeah, for sure. Part of the different a variety of different data structures that Redis offers in order to support these exact kind of use cases. Well, yeah, thanks again for y'all's collaboration on this, and thanks everyone for being here. Hope you all have a great rest of your week, and stay tuned for more great things with Redis and LangChain.
Alrighty, thank you, folks. It is time for Q&A. So Tyler, Nuno, Lance, if you can please go off camera and let's get going with Q&A. Thanks again for submitting all the questions. If you can stick around, Tyler and team will answer them live.
Yeah, hey folks. We got a lot of good questions both during the session and even before. If Lance and Nuno are there, I think they might be here as well. I have
Yeah, we are here.
wanted to
I think you guys need to let us turn on the camera.
Yeah, please do.
Yeah.
Nice. Okay. Awesome. Yeah, we got a lot of interesting questions that came in. I'd be curious to know if there's one that sticks out to you guys. You want to jump in? I know we don't have a ton of time, but I know I have one I want to ask you guys as well.
Yeah. Yeah, we can just kind of rattle them off because we saw them as it was going, and so have queued up answers. So
Yeah.
on the lost on the middle question, so have a look at some of the needle and haystack analyses. Greg Cameron's done some cool work, and some of these newer papers like Gemini also report. So they show you the recall accuracy with respect to location in the context length and also like depth. We'll share a link to some of those, but basically that gives you a sense for how the quality of retrieval based on location within the context window. You have a fact. So that's maybe the first one. On KNN, maybe that's a quick one. My sense is most vector stores implement something like HNSW. We'll share a link to that. Redis, maybe you guys can speak to your vector store. Probably implements something similar to that.
Yep.
The question was about the different KNN algorithm to use.
Yep.
Yeah.
Yeah, we offer both flat and HNSW
Yep.
For vector search.
Cool. Yep. There's one on agents with SQL and open source models. Yeah, my sense is we've seen generally worse performance with smaller open source models and agents. So actually, I would try something like Mistral Large, the new model that came out, just to confirm functionality outside of OpenAI, because sometimes agents can fail due to things that are like a little bit OpenAI specific, like OpenAI function calling or something like that. So pick a model that's high performance, not OpenAI, confirm it works there. Then think about reducing the model size. Try like Mistral 7B. If you need structured output, you can use JSON mode with Olama locally, or you can use, we also offer function calling with Mistral models as well. So that's maybe like a second thing to try with respect to agents plus open source. Mistral Large is not open source as a note, but it's just a good confirmation of functionality outside OpenAI ecosystem.
Yeah.
Final one, maybe. Oh yeah, any more here? Yeah, exactly. RAG plus role playing. Look at the generative agents work. We're going to share a link here. It's pretty cool. It does a lot on how to combine like RAG for memory with role playing and like personality and plus agents. So I think that's a really good thing to look at there.
Yeah.
Yeah, so that's a few on our end that we saw.
Yeah. Well, I'll answer one quickly from someone who asked about like why do we maintain two different like tables or indices for the data? I think it's mostly about flexibility. Like Lance, you mentioned some of these architectures, people might store images in blob storage or on disk or on files or within maybe a different solution. Here, we just happen to store everything in Redis. And for like absolute speed and kind of like pure throughput, you could definitely combine them in kind of a more manual solution. But this is kind of a way to just maintain some of that flexibility. And then I wanted to also highlight on how much faster is storing the vector store in Redis compared with traditional stores maybe on solid state drives or SSDs. And I think the answer to that, I mean, Redis lives in memory and RAM primarily, and the speed of ingestion and index creation in Redis, especially within the Redis enterprise cluster or architecture, is quite fast and would be much faster than any kind of disk-based method. That should make sense. It's kind of where we pride ourselves. If any of you guys are interested in that, we can definitely do some kind of follow-up sessions on some benchmarking we've done and dive into that space as well. Anything else? I know there's been lots of good questions here. Lost in the middle. I mean, there's one general question about like, hey, can you mention what varies from one RAG technique to the other in terms of results? I think it's maybe a harder question to answer because it's high kind of 10,000 foot view. The way I might frame this is like a lot of the things you saw in that diagram Lance and Nuno shared are all different kinds of tools that you might have in your tool belt, depending on your domain, like if you're working with PDFs versus if you're working with slides like we used in our demo today. So I think you might want to decide like, right, what's the domain, what's the type of data you're working with and the structure of the document, and use the tools accordingly. But otherwise, like all these techniques are just here to help you. Like, I don't know that there's like a prescriptive path that you should go down. Anything else you guys might want to add to that kind of question?
No, I think that's pretty good.
Okay. Yeah, anything else that's come in? Great. Okay, there's one more that could be interesting. Is RAG appropriate for summarization or just for questions that are more related with extracting specific information?
Well, the typical context is that you have a question you want to use to fish out documents. You can certainly have a RAG prompt that says summarize the retrieved documents. So it's kind of a false distinction, RAG versus summarization. You can use RAG for summarization. The point of RAG is you have a retrieval step prior to your generation, which could be like a question answer and a summarization prompt or whatever you want on the generation side. RAG just means you're retrieving that information from some external source. Where it's not as relevant is like if you just have one document, you have a big context window, you don't need to index it and retrieve it, just put it in, right? So that's kind of where you need RAG if you have a large corpus that you want to retrieve against. But if you have a single document you just want to summarize, just plumb it into the context window of your LLM. Don't do RAG.
Yeah. And I was going to also add, like, I think you kind of mentioned it, but really it comes down to like that final prompt for generation. Like that's where you're kind of given the instruction of like what we're doing. Like, are we summarizing? Are we answering some question? Are we maybe generating new content? Like sometimes I've seen like content creation pipelines for like maybe marketing or sales where you inject some information about the brands or user profiles fetched from some source. But the prompt is actually, hey, go create some new copy or like go generate net new information based on this. So it's definitely customizable. Yeah, this is great. Good questions, everybody. Anything else we want to address? Otherwise, this was really fun, and I hope we'll get to see some of you all soon. I see we have some interest in kind of doing some follow-up discussions with us later on, so we'll be excited for those. Oh, some questions just coming in now. Can you batch insert embeddings in Redis? Yes. We have a pipeline operation that you can send one network call and make a bunch of writes in one batch. Is ChatGPT Plus using RAG for PDF? Why RAG on OpenAI API doesn't seem to have any quality response? I don't necessarily know the answers to that. I think if you're using ChatGPT, like if you're injecting data directly into the prompt for ChatGPT, there's so many things that could influence potentially why. I know they've had some situations where people have claimed like OpenAI's model was like lazy for 1 week and they were just like not necessarily generating human quality responses. But if you're injecting the data directly into the prompting, or if you're using like maybe their retrieval like assistance API, there could be a couple different reasons for that. I'm not sure. Do you guys have any familiarity with that?
ChatGPT Plus using PDF. So why RAG with OpenAI doesn't seem to have any quality response? The response quality in RAG depends on a large number of parameters that could be very specific to your setup, chunk size. Yeah, I think without more information, it's hard to comment on that really.
Yeah. And hard to tell too, right? Like if it's more specific to like ChatGPT, which is a whole different kind of thing entirely, or like using the just generation API itself.
Yeah. I mean, RAG with OpenAI models is generally very, very strong, obviously.
Yeah.
So, like, the problem is probably upstream in your retrieval step if you're having a generation issue. Try LangSmith to actually look at the documents retrieved and then inspect them prior to the generation. That's usually the trick you want to do there.
Yeah.
Usually retrieval problem.
Yeah, absolutely. All right. Well, thanks everyone for coming. Camila, I'll hand it back to you. I think that's all the questions, and this has been really fun. Enjoyed chatting with everyone and getting all these great insights and questions from folks.
Thank you, Tyler. Thank you, Lance Nuno. I hope everyone really enjoyed the session. Thank you all for joining. We will be sharing the on-demand early next week, so keep an eye for that. And that wraps it up for us, folks. Again, thank you for joining us today, and I hope you have a great rest of your day. Bye-bye.
Awesome. See you guys.